So this is 4 and 5 from the pre-quiz. 43.2, 25.2 degree angle. First thing to do is to find these components. So this side is 43.2, cos 25.2 degrees. That's the angle. And then this side here is 43.2, sine 25.2. So 43.2, whoops, 43.2, cos 25.2. This is 39.089. And then this guy is okay, so what's the trick? Where does the launch velocity components, where do they go? Are they the initial velocity? Yes. Yeah, this is vertical, this is horizontal, right? So 39.089. Since this acceleration is 0, then this one's the same. These guys are always the same. This one's always 0. This initial velocity is 18.394. Right? This guy is, yeah. And then what's the trick? Yeah, so the final velocity when it hits the ground is opposite the initial. Remember that? That's the trick. This is also 0. This guy's 0, and then this is negative 18.394. And now it's like any formula we use is going to give us time, right? Because it starts and ends at the same elevation. Remember, it's net change in position is the mean, right? Okay, so I'm going to use V is U plus AT to find the time. So that's 3.74998. That goes across. I'm going to store that in my variable t. Actually, I don't need to. I can just go this times this, right? So that times 39.089. So, wow. On this question number 4, these are some things I'll ask you. I'll say, how far does it go? Well, 147 meters with 3 sig figs. What time is it in the air? 3.75 seconds with 3 sig figs, right? What if I say, what's the greatest height the rocket reaches? It's like, how do you do that? Yeah, you could divide lots of ways, right? You could divide the time by 2 and use that time to figure out the displacement, right? My favorite way to do it, though, is to just take this and do it all over again. Everything's the same here, except the final velocity at the top is 0, and then time, it could be half the time if you wanted to, or you can just figure it out with v squared is u squared plus 2as, right? But remember, the key is, if I say what's the greatest height, well, it's totally a vertical question, and just make the final velocity 0, okay? Yeah? Yeah, well, you could do both. You could do either one. If you could do both, and then you could be like, which formula will I use? Because they'll all work. Yeah, and you cut the time in half. No, you could just say, I don't know the time, and I don't care, because I'm Amanda Johnson, and I'm, the destroyer of the universe as far as projectile motion problems go. Yeah. Okay, so number 5. I'm thinking like Ghostbusters, right? Okay. For number 5, we're going to use this same launch velocity. Right, so U is 39.089. And you could do the same thing on your skill sets, right? Okay, and then this is still 0, which makes this the same. Negative 9.81.
Then S for
horizontal is 130, right? This is my favorite one because we're going to find time here, put it across, and do all of that.
That's the easiest way to do it. Time is the key.
So here I'm going to use S as UT, plus 1 FAT squared, but A is 0, right? So this divided by this is this. 130 divided by 39.089 is 3.3257. Put that across. I'm going to store that in T because I'm going to use it. This is V is U plus AT. So U is not 0, it's 18.394 plus negative 9.81 times alpha T, which is 3.3257. And then I'm even going to find S here, because I can, UT plus 1/2 AT squared. Okay, so 18.394 times alpha T plus 0.5 times negative 9.81 times alpha T squared. Whoops. Good God. Okay, there we go. Okay, so last. On number 5, I filled in the whole table. All I really needed was these guys, wasn't it? I didn't need to know. 146 meters is here, right? So 130 is like there. 130 meters is like right there. I didn't need to calculate that it hits 6.92 meters up the wall, but it's handy to know. In fact, I can't remember, maybe one of the skill sets says how high on the wall does it hit. Well, that's our vertical S, right? Okay. But this one says what is the velocity of impact as angle magnitude, doesn't it? Right? So we draw a picture of that, and it makes sense that it's going down because it's way past halfway. In fact, it's about to hit the ground, right? So it's moving down, it's way past half that time. That's why it's a downward velocity. So it's over 39.089 and then down 14.232. And I got that by finding the time from this divided by this. Time goes across, and then I use V as U plus AT. And then we've just got to make a hypotenuse and an angle, right? So the hypotenuse is .6, and then that angle is tan minus 1. It's going to be an adorable angle, right? .0 degrees. Are we good? We're good. But how good are we?